Good afternoon. Let me go over here. My name is Denise Glasscock. I work for Accenture. I'm a senior manager within our architecture practice. And one of the things that I watch and care for is the technology that we build around Red Hat. And so one of the things we're going to talk about today is how we look at the artificial intelligence and the intelligence and automation that we bring across the technology. So I'll talk to you a little bit about the ways that we look at how humans and machines work together, and then how we can also look at how we can separate some of those things. And as we go across this, what we'll do is talk about some of the principles and go through some of the methodology as well. Whoops. So how do we, today, one of the challenges that we have is that the systems themselves, people don't trust the systems and trust the AI technology. So what ends up happening is that we don't have the ability to actually create a fair and equitable solution so that the actual industry can look across it and actually use what the companies need as far as be able to create something that's truly automated. What we're trying to do here is talk about how we engender the idea, or how we learn to do trust and actually look across the systems. The people themselves, you're used to interacting, and if you keep interacting at high volumes, then you're not going to be able to actually be able to drive large volumes of automation. So the goal here is to create a trusted system that you can actually launch and drive your automation across. So the goal with this particular thing is to drive principles. The key principles here are around governance, monitoring, being able to drive skills, and actually be able to look at the design. So we'll go through each one of these. The goal here is that we want to be able to go through these principles, understand how they drive an AI environment, and how you can deliver these across your enterprise. So looking at how do we deal with governance, the goal here is that there's a lot of concerns around the more that I automate, the higher the risk could be, because I don't know what I'm actually touching or how the systems are interacting. Sometimes, particularly in the banking industry, or industries where you have high regulation, there's a lot of audit controls. So one of the things that we do is when we build in the audit functions around what we're doing with AI and what we build with intelligent automation, we look at how we can drive risk avoidance, so how do we mitigate. We also look at how we can leverage deeper analytics. So the more that I know, the more that I can automate, and the deeper that knowledge is driven across my system. The other things we also do is we look at how we can load policies, right? So there's the idea about we can drive financials, we can drive business policies, we can drive IT policies, which can do things like security and compliance, right? So all those things are driven in. Those are still driven by human, so you guys are going to go out and figure out what are the things I need to go do. So we're still doing workflows, and those workflows are still going to drive what's going to happen in the system, but the end goal is that the computations that the intelligent automation is going to drive it's in the hundreds or thousands of actions that may happen at a time. Given an example here is that when we look at the governance that we drive into a system where we have a regulatory solution, one action may drive 1,500 actions. So one solution that we have an example of is where we have an issue where that we're looking at an audit trace. The audit trace itself drives the system to say, I need to be able to change X number of actions, and those things, if you were to do it all by hand, eventually you're going to make an error. And so what that comes into point of is that the business can't handle the risk. So what you do is you add those things into your automation plane. That by driving that, you're driving out the risk. The same token, you're also logging, right? So all of that is captured in your audit logs. And what we've done on our system that we've built is we actually log that compliance. And there's actually a dashboard that we can use, and that dashboard gives us that compliance information. So depending on what your role is, you can either see what level of depth that you need for the compliance, or it's an executive dashboard that they just get the kind of the red, yellow, greens. So they depends on what level you want. The other things we talk about is design. So really the design side of this thing is where it's all at, right? Is we want to architect for the future. The things that we're doing today, we want to be able to drive preemptive actions. So think about it, it's a bit of machine learning, it's a bit about intelligent automation, but it's ultimately going into that idea of how far can I push artificial intelligence into my systems. The way that we use this as an example is on the orchestration layer, the more that we can design for future, the less interaction we have to have, meaning that the human element of this is that we're going to go off and do brighter, bigger things, while the system does all of the daily operations, and only notifying you when something's totally out of whack, right? So now you're dealing with those really high-level functions. The day-to-day stuff that should go through an operational element, those things should crank on. You shouldn't have to be doing those. So what we do is intelligent in as many ways as possible. So first thing you do is you design for intelligence on the very front end. So that means at the point that your system touches your initial source, so whether it's an application workload, or it's a software-defined element, or it's physical infrastructure, what you want to do is you want to drive the intelligence all the way down to those levels. And what that does is that when that information onboards into your systems, then you're getting that level of intelligence, and it drives through for your day 2 operations. The other things that we do is we build a tightly knit solution, meaning that it's bundled, right? So you may have several tools that go together. Those tools in and of themselves become disparate pieces, and when you decompose those things, you're actually running multiple things in order to get your environment running. The end result of it is you're still managing too many things. So by doing a tightly knit environment, you're building it up to one pane of glass. That one pane of glass gives you all the things that you want. As an example, you can use an ITSM tool, and on the back end of that, you have orchestration and automation that's building out what you need to do within your systems and your workloads. And it's all about the workload, right? Without the workload, I don't have anything else. So that's what we're trying to build out of. The other things that we do is we look for the agnostic cases, right? So how do I build as much of a freedom of open as I can build into this? So I leave out the lock-in, I leave out the opportunity for the inability to choose where I move. So all of these things are, like one of the things we do with Red Hat is, what we design is that we design from the open layer up. We're using subscription-based software because we want the support, but the end goal is that if I need to move up into the next level of upstream, I can. So now I'm actually running alongside of what's going to be coming down the pipe versus building something that I have to wait on if I were to use a vendor that has applications that are in a lock cycle. So as an example, if you want to upgrade something, in this case, you own the upgrade path because you're in the open pattern. You can add your templates, you can add your APIs. Everything that we do is API based. The other things that we do is we look for ways to be more preemptive versus proactive. Proactive thinks about things like thresholds, and that's good because that means you have historical data. But when you actually become preemptive, that means that we've applied some machine learning to this. So we've learned the action, and instead of having to learn it again and go over it again, we now built that in, and we can push forward on it. The end goal there is the system gets smarter as we go forward. You can do things like log scraping, and you could do things like keyword searches. All of those things lend toward the machine learning. But in the end, you want to build as much intelligence into that capability as possible. And one of the things that we're doing is we're working with Red Hat on how we build a true stack. And in that true stack, you're actually being able to take this and drive it to the next level. The other things that we do is we also use our ecosystem. So one of the things that you'll hear about, we do this thing called intelligent enterprise. And the intelligent enterprise is being able to take your partner system, your ecosystem, and leverage it to the fullest, right? So what you'll find in this area is that any one partner will have a good solution, but no one has the entire solution. So the goal here is to be able to build what you need. So that's why you want to build an open program, right? So the more that you drive for an API framework, the more open you are, the more capability that you can choose to build into it. This is one of the most challenging things you're going to talk about, right? So skills. How do you get the right skills at the right moment, and how do you take those skills and you drive them into your environment, and then you can replicate those at the same time? A lot of things that, if you're familiar with the OpenStack analogy of pet versus cattle, what we want to try to do is build code and build operational items that are repeatable. The goal behind that is that I can build skills that have continuous patterns and patterns that I can repeat versus unique languages or unique skills that are really hard to replace. You know, the one thing that we'll see around attrition is the more that you train someone in deeper skills, the easier it is for them to go get a job somewhere else, right? So the goal that we have is not necessarily to ban that, but the goal is to be able to create as much of a continuous pattern as possible, so common patterns. And the outcome of that is that we can do repeatable skills. You can also drive those skills into lower cost so that you're training the younger generation and you're moving yourselves up into the more complex task. So the end result here is, you know, build open, drive models that allow you to have more community, and then build out training programs that allow you to drive capabilities across multiple environments. The other thing is building for the next generation, right? So one of the things that we talk about in the way that we look at our clients and we work with our clients is how we talk about things that we monitor. So how do we display things and how do we talk back around what are the key features that the clients want to see? So these are some of the things that we talk about, right? So the things that we have around how do we make sure the executives have the information they want and need? How do we build growth patterns so that we can actually take our skills and technologies and build them to the next level? The other things that we talk about is how do we prove a compliance and audit pattern? Particularly the banking industry and the insurance industries, telco industries, healthcare and government, all of those guys have really stringent compliance and audit requirements. So one of the things that we do is we look across how we can build common patterns for those as well. The other thing is by driving ITSM and ticket automation. So things like BMC or ServiceNow or, you know, any of your automation technology or your ticket technologies along with ITSM, we can back in that with Ansible or Cloud Forms or both, and now we've got actual CMP with automation, or we've got the ability to drive more capabilities through those technologies, so we can actually bolster those and make them more powerful. So what I want to do now is talk to you about a use case, right? So let's take some of these together, and I know I'm going kind of fast here. I want to give you guys time for questions. So the business challenges that we have, right, is common CIO questions are, I need you to build me something that's fast, that's flexible, that's audit ready, that I can actually build with the resources that I have, and then do all of that for a lower cost, by the way, right? So the end result of it is what we've done is we look at how do we build intelligence, how do we drive economy, how do we build a workforce that has skills that are flexible, so we call those liquid. And then the other things we look for is economy places that we can build off of, right? So whether it's a skill platform that we're looking for, or whether it's something that we were talking about around how do we drive either a cloud-enabled platform or a cloud platform, so how do we move along that maturity cycle that says I need to build automation at my traditional layer, which is my foundations, so the things that I would normally do with playbooks, on up to the fact that I can build in intelligence and eventually move toward more of an AI type function where I'm actually able to do that preemptive technology. The end goal of it is that we want to build trust across the systems and trust across the human and the machine so that you allow the platform to do what it needs to do for you and you're not trying to intervene. The example that we have in this is that we have a banking client that they had a very expensive ITSM with their own service management back end. They were already working off of their own CMDBs, so they had multiple CMDBs. And that whole back end was not going to go anywhere, right? That was something that they had invested in. It was multiple millions of dollars. What they were looking for is how can you touch this without interrupting it? At the same time, you build it into the new. So what we did is that you can build the UI to it, right? So we're building a service UI. That service UI that talks to it is simplistic. The end result is we're talking across APIs or across SOAP or across Java. We're using common language, right? And then the end goal is that we put that through an automation and orchestration platform that's able to actually communicate, and you're putting through the templates, the policies, the rules. So all of those things are being adhere to, and you're actually able to communicate those across whatever audit trails you need, whatever compliance policies that you want to add into. And the other things that we do is we actually look for intelligent placement. So we look for ways that we can build what's the right place to put this at the right time. So think about it this way: if you're processing a migration, so you want to move from one technology to a new technology, and so let's say you're looking at an older traditional capabilities, and you want to move those to new virtual or new OpenStack or new cloud, right? As you move forward in those things and you begin to put hundreds of workloads at a time into those environments, those requirements are changing as you start filling up your containers or your virtual environments, and you start to push your system. For you to make a decision as to what goes where, you're bound to make a mistake because you're not going to be able to do all the computations that are needed in order to make that decision. What we use is we use a series of tools. Now those are integrated, so what we do is we use Ansible to do all the integration, so kind of like the glue that puts it all together. And it helps us to do the automation side of it. At the same token, it's building off of what we're trying to build and what we're trying to do at scale. So the scale is that we can move thousands of workloads over a period of time, and the system is actually being able to decide where that workload goes based on the policies and the rules that we put in place. There's checksums in there as well, but the end result is that you can do a single check on an environment. You should be able to come up with the right answer, so you're not having to check across the entire environment. So you're able to do small checks. The end result of that is that you end up with true trust, and now you're actually computing at scale, and you're driving out the common problems that you would see. An example would be is if you oversize a virtual machine by a large bit, and then you start computing against that, you'll end up with a lot of reads. And the end result of that is that you'll end up hanging that environment so that it'll look like it's not computing fast enough, so you end up with a lot of I/O problems. In reality, all it is that the system is oversized, and if you could resize that as an ongoing process, one of the nirvana things is that if you could put a system in play that says, I'm going to give you 1 or 2 templates, and then I'm going to right-size that template as soon as you start putting a workload onto it. The end result of that is that you would have less libraries to have to monitor. You would have a higher output of optimization because you're building off of 1 or 2 or 3 templates. So the end result of it would be is that you're able to drive higher efficiencies because you're not trying to maintain hundreds of templates. We've gone into environments where clients have had, the gold image, right? So they have this idea of I may have a few hundred templates depending upon what my engineering versus my developer versus my operations guys need. In reality, that sizing is still too many, and you can't possibly keep up with all that library. So the end result of it is running out a series of sizing tests of saying what is the sweet spot? Is it a 2 CPU template that has X gig of memory and X gig of disk, and then once that workload hits it, then you right size that workload. That would be the great thing to do, right? So you can either oversize it and then bring it down to the right size, or you can start it from the bottom, meaning that you give it minimum sizing and then you upsize it as soon as you put a workload onto it. The goal there is that in the end, you should find what your sweet spot is. So once you start to figure out what your workloads look like, then you could build true images and templates against those. Good?
It's also about how you're actually optimizing your environment to be more accurate to what you need from the application point of view, so that the benefit is extended to the application streams to develop and deploy the things in whatever way that you need it to be.
In this example, we're using what would be an intelligent automation environment, and these are the things that you would think about, right? So there's more than this, but these are typical requirements that you see, and then the goal here is that as you look through what each of these requirements do, you're deciding on in effect you're deciding on what your intelligence level is going to be, how far you're going to automate, and as you go through each one of these, the outcome of that is that the system that you're building should be more responsive and should be smarter than what you have in something that's just off the shelf, right? So the things that you can think about, whether it's Cloud Forms or Ansible or how you stitch it together, the end goal is that these items that you're looking through around what are the things that I want to think about, and you're probably going to add to these, right? But that the end goal is that I now understand what my automation needs are. I can drive intelligence into those automation needs. And the things, simple things like adding playbooks, and then on top of that, those playbooks, you can add things like we use Turbonomics and we use Nuage for our networks. You can choose many of the other partners as well. The end goal is, one of the things that we like about Cloud Forms and about Nuage and Turbonomics is that we can fold all those service providers together, so you're getting a one pane of glass, so you're getting the most you can out of the tool that you have. And then also, because it's an open API framework, we can add tools as we need to, or add additional capabilities as we need to. Anything else?
So just to add a little point on that, so because of the strength that we have through the Ansible that we glued with, so it is not only from the stack of the infrastructure, it goes beyond the infrastructure layer and the application layer, and it touches the network part of the things that we can automate and look up the things that we wanted to do from a whole stack perspective, instead of just sitting at one layer and develop the automations around that particular layer. So it covers the entire stack instead of looking at one particular specific area that we need to automate.
And one of the things we should probably iterate about emphasize, I guess, about this is when we look at the systems, we look at them holistically. And the goal there is that if you have a tops to bottom look, right? So first thing that we do is we look at the business cases and make sure that we're following the business case so that IT is following business. And then the end goal is that the application needs dictate what the infrastructure resources are going to be developed for. And then the end of that is how do I operate all this stuff, right? So if you look at it as a holistic pattern, to get the end result of it will be that you're able to come out with the technology that you need, and you're meeting the, not only the minimum requirements, but you're meeting the requirements that you need without oversizing, over-developing. So where do I go from here? So these are the things that we talk about is, you know, the overall AI benefits, right, AI is here to make your life better. The goal that we have is to drive capability across the operations layer as well as the technology and even the business, right? So the big thing here is that if we're not making our lives easier, then we're not doing it right. So that's the goal here is to look for the additional, where do we need to address our concerns? How do we drive those concerns out into intelligent layers? And then as we build those things out, we look at the benefits that we need to do. Think about the things that you need to drive: trust, fairness, capabilities that do things around interoperability. The other things that we want to do is the human side of this is that if you're doing repetitive things, then automate those things. But make sure that what you're automating is a process that you want to repeat, right? So don't repeat the bad. Make sure that you're looking across these things. So you do have to do some homework. The other things we want to do is look at what layer of intelligence you need to provide at the machine level. So the end goal is that as you get better in what your environment's able to do, the machine and the learning that you do along with that environment picks that up and you become more preemptive. What else we got there? Anything else? Oh, yeah, and the last thing is the adaptive and self-regulation. So the goal here is that you want to also be able to do something that's self-service, right? So the users, the way that we optimize our environments is we provide self-service portals. The way that those portals are managed and actually optimized is through the ability to create agility. And again, that's through automation and intelligence. And then the other thing you want to be able to do is you got to be adaptive to it, right? So the things that we're trying to build through is getting a client an understanding of what their needs are and how they can build those for future. So again, that's the idea of the future proofing or future architecting. And then the thing that you want to do there is, another good example is clients a lot of times is they'll build these really complex systems that take years to build. Well, now you've probably not lived up to the technology pace. And the outcome of that is you haven't been able to drive your change along the lines of how fast technology's changed. So being able to not boil the ocean kind of idea, and then building up through sprint level technology paces. So that way you're getting the timeliness that you need across your systems. I think that's it.